Let's go. Oh, there we go. Yep, now it's working. Hey, welcome to Made Up of Wires. I appreciate everybody who shows up every day. Did the music just decide that it's gonna stop? No, there it goes. Just quiet. Today we're going to decompile Samurai Showdown for the Neo Geo. 118 megabits of fighting action. This was, I think, the first Neo Geo game I ever played in the arcade. Not that specific copy of it, but Samurai Showdown in general. I never had Metal Slug. Metal Slug, I think, is one of the best Neo Geo games. Never had it in any of the arcades near me. I found a Pizza Hut that had a tabletop version of Samurai Showdown, if I remember correctly, and it was amazing. Hello, good to have you back. Of course, we're gonna look at more at Symphony of the Night. I'm gonna talk first about something that I just learned and was plaguing me all weekend. And now I know it, and I will pass on what I learned to you, and then you know it, and now more people know it, and we can all be happy knowing this together. So, I don't do a lot with binary formats. It's not something that I work with a bunch. So I have assumptions, and I think we all, there's a like manifesto somebody wrote about assumptions programmers make about time or calendars or whatever. And I think that's a good read to understand how little you know, but also how much do you need to know to solve a particular problem in the domain that you're trying to solve it in? Do you need to know everything about how the Gregorians set up their calendar? Probably not. Do you need to know some basics about time zones and that you should probably store all your dates and times in UTC and convert them at display time? Yeah, you should probably know that. So what about alignment? You should probably know something about alignment if you're going to do decompilation. And that's what we're going to talk about at the start here. Two things that I learned this morning that are a little different from what I expected. In all of the PSP files, I shouldn't say all the PSP files, in the PSP overlays, there's something called the MetroWorks overlay header, and we're using version 3 of the MetroWorks overlay header. And that shows up as a MWO3. And we've always treated that as 128 bytes of data. But as I was looking through weapons, it seemed like it was 40 bytes. The only number that made sense was, hex 40 bytes, 64 bytes. That was the only number that made sense. And then I was talking about this in Discord, and Project Oblivion sent me this link that apparently came with Code Warrior for the PlayStation 2. This is the same as the PSP overlay version. There's a couple interesting things here. We had been treating names as 16 bytes. They're actually 32 bytes. We've just never seen one that's more than 16 bytes in this project. But the overlay header size is 40 bytes. It's not 80 bytes. But every time we look at where code starts in these overlay files, code starts at offset 80. And why is that? Well, it might be easier if we change the alignment to a hex value. The alignment is at 80, and it turns out that code doesn't even start at 80. It actually starts at 40. Or 64 bytes in. People still use VBA still exists. Oh, VBA is what the Office apps use, right? I forget about I did some VB a long time ago, before we had all these wonderful languages that we have now. All right, so it starts at 40. Oh, there's Office script. I didn't even know that's such a thing. Is that Office version of JavaScript? Hello. Hello, loading personality. Good to have you. I'm glad you have the subtitle. Well, anyway. So what happens is the header's 40 or 64 bytes, but our alignment is at 80 bytes. And I'm going to try something to get this to work more like I expect it to work, because it's not working like I expect it to work. And actually, we're going to do that with weapon 0. I'm going to undo a bunch of this stuff. Make sure that this is building again. Good. So we get shifted down. I wrote this tool called MWO dump to try to figure all this stuff out. And what was bothering me is that the text length is 68C, but if we look at where that ends in the offset in that file, that file actually goes to 6cc. The next byte would be 6cc. So 68c is in the middle of some other function. So what is this number? And if we add 80 to that, we're at 74c. And 74c is, no, 70c? 70c is well into data. That's too far. But if we treat it as 40 bytes, our header has 40 bytes, then things start to make more sense. Because we write this MWO header. The MWO header says, I have 40 bytes. My job's done. That's it. 40 bytes. That's my size. And then the text segment comes in and it says, I'm going to write some stuff. I have, how much stuff does it have to write? 64C. It has 64C worth of code to write in size. And so it starts to write that code and says, what's my offset? My offset's 64 bytes into this file. I can't do that. I need to be at a 128 byte alignment. So I need to pad this 40 bytes. And then I'm going to write my 64C bytes into the file. And so my total size with my padding was 68C. And that gets me out to offset 6cc in the file. I have always thought of the padding in a file as the trailing padding as being part of that particular section or segment. But this MetroWorks overlay format is saying, no, the padding is part of the segment which follows, and we're going to attribute that space and the size to the... So even though code is not going to start until 80... offset 80 or 128 bytes into the file, that 40 bytes of padding, that's considered text. We can see that, and Splat actually works if we do this, and there's going to be a couple things I'm going to try to get this to work in Splat as well. But if we take data actually starts at offset 700 hex, and we can build this with that offset, and that builds fine. But if we look at this function, then this function gets all the no-ops to pad this out to 700. And the compiler's saying, I didn't put those no-ops there. I don't care about the padding. I just write, to the end of my function, and that's it. It's the data that cared about the padding. And we can model it that way in Splat. We could say that the data starts at 6xx. Or 6cc. And if we look at data, right now, the way we think of data is starting at 700, and that's where the first global variable starts. But if we build this, it still builds fine. The alignment works. and we automatically get the padding, but there's no variable that corresponds with this padding. It's just put in there either by the linker or the compiler. I'm not sure which. And so we don't have to worry about it. And it just gets there. So what I want to do, I want to try a few things because we should be able to get that to work here as well. I'm going to try to move the MWO header into this segment. And what I'd like to do is say at, can I specify a size here? Let me go find my splat documentation. No, I don't think there is a size, and that's unfortunate. Let's try this. So we're gonna say that this starts at 0. Because why wouldn't it? And we're gonna set our VRAM to 0. And we're gonna say that our C starts at 40. And is that gonna work? I have no idea. So let's try it. Let's see. I misspelled segment. Somebody misspelled segment. Segment. That wasn't me. That wasn't me. Oh, we can't do this. It was me who's misspelled segment. Our build tooling is not going to support that at the moment. Bummer. Anyway, I'll look more into that. But something I learned. MetroWorks headers are not 80 or 128 bytes. They're 40. Let's stage all of this. I'm excited. Why? No, that shouldn't exist. That shouldn't exist. No, I do want to get rid of all those things. And then we'll get back to Richter. Project Oblivion has all of the weapon headers working. So the reason I wanted to figure all that out is because I couldn't, the heuristic that we were currently using, which was that the header was 80 or 128 bytes, sorry, 80 hex, 128 decimal. That didn't work for many of the overlays. It probably works for all of the stage overlays, just coincidentally, but it didn't work for sorry, gotta quit all this stuff. It did not work for weapons. And so I was racking my brain as to why this would be. And now I know. The other thing that happened was my MetroWorks CC gap change made it in, and that would be nice to do. So your compiler most of the time can emit a dependency file, and that dependency file says all of the other headers that you included along the way, and then you can give that to your build system, CMake or Ninja or Make, and you could say, hey, when I want to rebuild this file, here's all the headers that it depended on, and so if one of those changes, please rebuild that C file as well. And now MWCC gap supports that as well, and I need to update our project to grab that change. Oh, Eldritch is loading me up. Yes. Thank you, Eldritch, for following up. Yeah, and I say this when asked about AI in the U.S., which is my jurisdiction, and who's gonna come after me if I screw up. Our copyright laws protect reverse engineering and decompilation as long as it's creative work, and what we produce is not something that's done mechanically. And so my personal legal philosophy, which should not be anybody else's legal philosophy unless you consult your lawyer, is that I should stay as far away from AI as possible, because if that decompilation becomes a mechanical translation as opposed to a manual translation with creative expression, then I'm in big trouble, and I violated all kinds of international copyright laws. Yeah. Oh, does it? I thought the same thing. It is possible. Let's try that. Let's try that real quick. I don't really want to do that, but let's try it. So we're gonna do splat SPWO. Rebuild. The other thing I have to get in, so like I said earlier, I have all the versions building in one big Ninja file, which is nice. All the prereqs for that I think are in. So let's try that. Let's say, oh, I can't do it. I can't do it because, again, it's our build system. When we're generating our Ninja file, will this work? Where'd my misspelling end up? Segment. Here's where it is. Maybe if I do this. Yeah, here we go. Okay. Now it'll work. Let's try this. We're gonna call this MBOBO header. Start is at 0. Type is bin. Line is 80. And is that enough? You can spell a line correctly. Let's try that. Yeah, there's other things in here that I need to look into. Oh, there's no coalescing operator in yeah. So this is a hack to get around this. We're gonna ignore MWO header in this section. And let's see if that does any better. Yeah. But afterwards. No, for bin? My type was, oh, bin comma. Oh! What? This isn't quite right though, because it's still 40. So we really need a yeah. So we got this working. Let's go. Are we cooking? Nope, not cooking. And if we look at the build file, I think what's going to happen is the same thing that I saw before. But let's see. Oh. No, now I'm not sure what's happening. It did align. Did I screw up my offsets? It did align this properly. So what is missing? Do I really need the alignment here? Maybe I do. So there's something in here that I'll do one more thing and try to see where this difference is. Yeah. Oh. This is weird. I don't like it. Burn it with fire. Is that gonna work? Kill it with fire, I mean, of course. Yuck. Yuck! Okay, so this works. I don't like it. So we have to know that, and do we know this? That VRAM, basically to calculate VRAM, we need to, let's do this. We move VRAM up here. Yeah, no, unfortunately our tooling is not flexible enough to handle this case. But I think there might be something there. So thanks to Dizik for making me look into this. Jillian Sneed. Amazing. Thank you so much. I think good things will come out of it. Recreating bytecode as Java code absolutely counts as decompilation. I mean, any translation from machine code, and JVM is a machine, virtual machine. I think that's fair. I'll take a little bit. Okay, so what does that tell us? I think it's mostly we just learned more about things that I didn't know earlier. I don't know if it really it helps my understanding of the tooling and how this came to be. So as I was going through this and trying to figure out where these offsets are, the other thing I was looking at was how are these files loaded? And we don't have references to any of these weapons in the code that we've decompiled before. The DRA main, or like DRA is the game engine, and the PSP version of that references a lot of files in HD bin, which is largely the JP 1.0 version of all these files, and it's not PSP bin, which is the files that the PSP uses. If you haven't seen it before, nice new layout for checking the build. So I went digging into ps.elf, which is an elf file is a binary, can be executable, it could be a library. It's something that is used by the PSP, uses elf files directly. Linux executables and libraries are elf files as well. ps.elf is the Symphony of the Night program on the Castlevania Chronicles. What is this? What game is it? Dracula X Chronicles. Sorry. And in that file, there's a bunch of symbols that are linked to tell each overlay where it should go in memory. But not only is it necessary to know where that overlay should be loaded into memory, there's a function in every one of those overlays except for DRA that needs to be called to initialize that overlay. And so there's a table in ps.elf, and the name string in that table is the file that's going to be loaded. And this is very small, so I'm going to make it bigger. And the address there is the address of the load function. And so that's another thing I was looking at when I was working on weapons, is how do we know this address? Because nothing in the code that we've decompiled so far has any reference to this address or a symbol name or any. There's no symbol in the file to go to. So how do we know what that is? And so what I believe is happening, we export this symbol as part of the elf file that gets generated before the overlay file gets generated. I think they were probably using those to link ps.elf, and that's the last thing that would be compiled in the project. And then they know what the VRAM addresses of all those overlays are. So we have all those now. Project Oblivion was looking at this as well. He came up with a different heuristic for finding that and was able to find that a slightly different way. But this is kind of a canonical reference of those addresses. What does all that mean? Who cares? Let's decompile something. Okay, so I think we were looking at this US. A few things there. I think just continuing to move down probably makes sense. So this is the Richter boss. A lot of the functions are going to be the same as Richter. As I go through them, I'm going to look at duplicates to see if these are similar. I'm not going to decompile any duplicates. Don't have to. Unless the duplicate is, I don't know, 5 or higher % different. Oh, no, sorry. Catching up, load personality. Stircat, interesting. Have I used Stircat? The one that I found recently, it's the opposite of that, Stirtok, STRTOK. You give it a substring and it will split your string, but it does it destructively. It'll iterate through the string, finding the delimiter and replacing it with a null character to terminate the string. I had some fun with that, not realizing that it was a destructive operation. That's how, like, the witch command, like, you know, witch Python, and it tells you which Python. That's how that works. All right, so you don't want to execute that. Not too long. A short-ish function. I'm gonna look at decomp.me. Take an early tab somewhere in here. search is taking a while. Let me, I might need to refresh. Yeah, it needs to know that I'm a human. Joke's on them. Yes, I haven't worked on this yet. So we are going to do the PlayStation version to start. So a pretty small function. I want to check these globals. Typically we can just get rid of. So if you're not familiar with decomp.me, it is a collaborative decompilation IDE that allows you to choose most of the compilers. I shouldn't say most, many of the compilers that were used as part of SDKs. Fortunately for the PlayStation, this is a version of GCC, and we still have the patches available publicly that we can use this without much complication. The MetroWorks stuff is a little dicier. Is that the right way to say it? Current MetroWorks, as far as I know, is offered by Freescale. I don't know if that helps or hurts anybody. So I'm looking for this offset. I want to know if it's within any of the structs that I've seen before. So I need something 801.822, 801.8. So we don't see any other known symbols around that space. And nothing is referencing this directly, which is not ideal. I don't know why this. Oh, because I looked in data. It should be referenced. Yeah. Okay, it's referenced by functions. Good. Makes me feel a little better. And we'll look at. Oh, it's part of BSS. No, that's not really BSS. No. Come on, I can Vim. So this looks like it's just going to be a Sign16 array. And so SPIM couldn't figure that out. It just treats everything as 32-bit. We don't have to worry about that. So it's going to be a Sign16 array, which is how animations are stored. This FC probably is going to be a Sign16 array as well. Oh, maybe not. Okay, not worried about that. And then now we can go through and clear out all of these known symbols. We have a function here with a big hex number. Jillian Sneed, by the way, awesome. The Snatcher reference. I think that's a Snatcher reference. So this is a small function. I'm just going to get rid of all these. And then we replace these with struct access. There's some magic numbers in here. We have a factory macro that will build this up, and we know what the constituent parts of this number are, but they're bit packed into a 32-bit value. So any gric is going to become gric dot, and any ric is going to become ric dot. And then there's just this position xi high and player position I high as well. And then this should compile. And we're at 89%. So there's some issues here with how this is being loaded. If we change this to, it looks like this is less than equals. I think that this is going to be fix -1. So that looks like it was that was the only thing that M2C didn't get. So that ended up being pretty simple. All of these, not all of them, many of the hex values are what we call fixed point numbers. They're like floating point, but worse. Or for the PSP, or sorry, for the PlayStation, those are, for Symphony of the Night, those are 16 bits numerator, 16 bits fraction. Let's try to get this in and see if it works. I can talk more about that if anybody is interested, but the main takeaway is we don't have floating point. So that did not work. And we could see why. So somewhere we have a 62 and we should have a 43. So that's probably a, no, it's not an operator. I was going to say maybe it's an operator. Actually, it might be. The way that MIPS math instructions work is by setting the opcode to 0, and then the remainder is some values to set what function in the math operation it's going to be, and then operands to that math function. So let's see where I screwed up here. Somewhere there's going to be, I think, either a comparison that's wrong, or it could be an offset that's wrong. Let's figure out what instruction this is. So we're going to look for address 39438 in that assembly. And it's the signed less than, and it's right in that area that I was mucking around in. So something oh yeah. These are backwards. So these just need to be in the opposite order. Not quite, eh? Yep, there we go. End up being a simple one, which is nice. It's nice when it's small things like that. A lot of times, if you screw up something, a type, or even a comparison like that, you might generate additional instructions, and then that destroys the offsets of everything else in the file, and the diff looks really bad, and it's hard to find because every address then after that has changed. So let's keep going. I haven't, what's kind of maybe it's sad, is that the right word. I haven't actually played Symphony of the Night lately, and I haven't even like watched other people play Symphony of the Night. This looks like this next function looks like a duplicate, and I think the function after it is a duplicate as well. We could look at that if people are interested, but it is mostly it's just mapping addresses and not anything super interesting. So I'm going to keep going. I am going to look at the next function after those. Also a duplicate. And the one after that is also a duplicate. The ones following are known, and then we have one that didn't get a name. I could name those other ones actually. It's going to be decelerate X and decelerate Y. This is going to be a set velocity. So I'm going to make some notes to myself. And we'll keep going. Anytime I see that these are duplicates, I'm just going to skip them. And the reason I'm skipping them is because, like I said, it's just mapping globals. So the S73 mentioned, here's our first one that doesn't, we haven't seen before. Does decompiling Java bytecode count? There's some interesting things, not just with Java bytecode, but with jars and the way Java packages things. At my last real job, hey Willie OD, one of the things that our CTO liked and wanted to have was basically a way to drop class files in that was in the class path before the jars that actually included those. So if something needed to be hot patched, you could do that. But we were moving our deployments to Docker, and that meant we didn't really have a mutable file system to drop class files onto, and the hosts were all ephemeral, blah, blah, blah. And so he wanted me to come up with a way to do something similar. And so what I ended up doing was I already had the build system basically comparing the contents of jar files as opposed to the jar files themselves. Jar files had a lot of metadata related to the build time and other things like that changes every time you build them. So it would extract the jar files, compare bytecode for all the files, and if nothing had changed, you would use the old version of that file with the old timestamps. And that helped us reduce the size of builds because the way we layered things, we put slow moving parts at a particular layer. Those would always compile to be effectively the same thing, and you didn't have to store that extra layer. We had to store or keep track of every build that could possibly be deployed into production, basically for eternity. So we didn't ever delete anything unless we could prove that it had never been in production. So he wanted this jar file thing. So I came up with a hot patch method of we would build the application like normal. It would look at the class files that differed from the last time that we built, and then it would create a layer on top of the last production version just with the class files that had changed, and then we could do hot patches with like the minimal set of changes. I thought that was pretty neat. And it was super cheap, a handful of 2 or 3 class files. You had guaranteed binary compatibility, which people don't think about in Java, but it is a thing. There is binary compatibility in Java. Yeah, it definitely has a lot of information. And what's nice is like it has all the debugging information. I did some stuff with oh, what was the library? We had a couple bytecode generators. And what did I come up with for bytecode generation? I think it was related to how we were tracking transactions, or maybe timing for what? What would we have been timing for? We had some shared batch systems that I worked on as well, and I spent a lot of time basically designing a scheduler for that and making sure things were fair, because you had, you know, thousands of customers potentially sharing just a handful of hosts running batch processes. This is gonna be a signed 16 array. So I think part of that was like injecting. It was database safety. I think that's what it was. Basically injecting some code to keep track of the percentage of time being spent waiting on database, and then we could tune, basically pause threads that were hitting the database too much. Some of the things I miss about Java. I say that we can't completely rely on M2C, even though M2C basically did all this work for us. It doesn't know to put the dots in the right places. It knows everything else, though. Yeah, so I thought Java had a lot of nice ergonomics for messing with. I want to see if these globals are defined already. There we go. Messing with the compiled output, generating things. I liked it from that perspective. I didn't really like it from many other perspectives. The language was getting better. Java, I quit Java-ing when they started going crazy with their version numbering. So what was that, like Java 11 or something? Like Java 8 was around for a while, and then they were just like, yeah, we're going to do a new version every 2 months. 9, 10, 11, here you go. And Oracle was doing funny things with, like, OpenJDK is still around, but everybody was worried that you were going to have to pay Oracle. 160E looks like part of Rick. Thank you, Dizik. Appreciate that. So let's go look at that before I continue on. Let's write a linter. How about that? That is a good idea. Oh, it's a good idea. When I talk to my family and they ignore me, I always make a voice for whoever I want to respond, or just the group in general. And that annoys them to no end. Okay, so one of the things I did, because I saw this come up quite a bit, and it makes portability not possible, is made a linter basically that had reserved addresses that we knew were part of other structures. And so I'm going to do the same thing here. So we're going to look at, this is Rust, and I'm going to suck at it, so excuse me beforehand. We have Soten lint. This is one of the, it's in the lints directory. This is one of the things that endeared me to this project, was the fact that not only did they have a bunch of tooling that they created themselves for decompilation, but their commitment to code quality was so much that they created their own linters to go through and fix things up, and just ensure that code quality remained high. I mean, and these lints aren't just like stylistic nitpicks. Like, You need to use, what? A space after your struct start. It's things like, there should be an enum here, so use the enum. Let me see if I can remember what this is. I think it's in linter. So I think it is, no, not regex linter. Let's look at main. Where are my linters? Entity range linter. There we go. And this is hard coded for the sake of what we're doing here. I'm going to just copy paste. What would be better is if this was a like a more generic linter that these could wrap, but that's not what I'm going to do. Don't do this at home. Don't try this at home. So we need to go grab the ranges for Rick. I need to export this. I do need to make it public. So basically what this does is it looks at variables, automatic variables. They're always going to start with D underscore, and then we put the version, so the US underscore that comes with it. So it looks like one of these guys. And something like grick, we want symbols for all the fields in it. And the reason we want that is because it makes it much easier to identify as opposed to an offset. And we could just change things like underscores to periods. So, but we don't want those to, the ones that we don't have mapped, we don't want them to show up later on. So we'll look at grick. Grick starts here. And it's going to end 3DO later. And then let's look at, are there any other big, G-dialog is another one that might not be the worst to do. Those are the only ones I have size for. The Richter ones will be caught, so I'm not worried about those. So let's see if I can get this to work. As if I'm competent. It compiled. Oh. A bunch of them. And that's why this exists, because I want to find things like that. And you definitely are right that 160E is part. I didn't even have to add the grick. It's just part of Richter. So let's do the math and figure out what it is. So we know that. Let's go find. We're going to start with our bad offset. Subtract the start of. This will actually start at C. No, it'll start at 8. Sorry. And then we're in. What am I doing? Oh. Oh. Oh, oh, oh. This is not part of Richter. What? Oh, my message was wrong. Thank you. You're probably all saying this. This is not supposed to be part of G entities. It's supposed to be part of GRIC. We're going to run this again. Better message. And I'll do this math again. So offset 346. These are a pain when they're not listed. So we need to add that offset to this. And we can take that address and look for that. Oh, and fail. And fail. Always a fail. So it's part of timers. It's the 8th timer. I can do var inside of format. I'm sure you're right. I feel like there was something, either maybe when this was started we couldn't do it, like the version of Rust and supported that we were using. I'll run this again. Yeah, thank you. So what I really would like is a way to, there's a couple libraries for parsing C. It would be nice, and we know what timer 8 is. It would be nice to actually like parse these header files and get. So instead of having a hard-coded thing like, oh, this is timers at this offset or that offset, just read the struct and tell you what the field is. And then you could rewrite it. You wouldn't have to. All right, let's try that. I actually think, if I remember correctly, the Rust that we're using in CI might not. I just use like the Ubuntu default Rust. We don't use Rust up, right? Rust up is what will give you a local VM equivalent. This is nice as well because it lets me get rid of this global. Let's see if it works. Doesn't work. I could be wrong. My offset could be wrong. Ooh, not good. I'm gonna change this. Let's see this. Am I getting a? What's the issue? And what is hex 28? Chat, what's Hex 28? I replaced the wrong one. Oh. Thank you. Still wrong. Oh, these are out of order. Nope. Nope, that's right. That seems right. Where did I screw up? Is like you're yelling at me. He thinks it's Rick. Oh. I'm just... I have the wrong offset. So it's at E. So we're 2 away, so we're at offset 10? Or index 10? Did I go the wrong direction? I went the wrong... Oh, I went too far. Too far? Not far enough. Didn't go far enough. There we go. Why did I screw that up? I thought it was... Oh, hex 16 was hex 16 away, which I was thinking of decimal 16, which divided by 2 is 8. Hex 16 divided by 2 is 8 plus 3, 11. It works. Good game. Good gamer, gotta go. Good going. We did it. That's what's important. So let's look at the next one. I'm gonna move my duplicates over here. So I can get to them without moving everything around. Just continue my ridiculous number of tabs. This next one's not a duplicate either. I had this open already? I guess so. Is that right? What? Oh. Gotta tell baby copy what to copy. Close these. Lint open. Yeah, 74 is wrong. This should be... Oh no, E4. E4 is right. Good game. Yeah. It is a game, isn't it? For more reasons than a few. We're going to run into something, similar things. This looks close enough to that other one that it probably is in GRIC as well. Maybe even a timer. 5FA looks like it's in GRIC as well. Nope, that's not. Those are BSS. I don't think there's anything there. So this one I think is going to be a GRIC timer. 210 is, oh no, it's not. That is going to be an array. Set speed is going to be a fix as well. So this is going to be 1 1/4. I should get this compiling before changing values like that. That would be smart. Completely unlike what I should be doing. All right, how far are we? I'm gonna invert this and see if that affects how this top part's getting compiled. Actually, the way that this is getting done up here makes me even more convinced that this is part of GRIC. Let's grab those offsets. .340 that is, and so once again we have to go to game.h. Add this offset. And we're here. So this time we're 10, so that will be offset, or timer 8. And I would expect that to compile nicer. Okay, so the 1608 is going to be as well, and yeah, Dizik, I think you're right. This is going to be timers as well, and that's probably why this isn't. What was this first one? I should have just done a copy pasta. So we're setting these to the same thing. 1608. So this is before it. A C E 0 2 4 6 8 7. No, it can't be 7. 7 earlier. So this timer's 1. And I like setting these to decimal values. Still not perfect. Oh, because we're not returning. And I didn't end up inverting that. So yeah, I think that's it. I might be wrong about those indexes. We can figure that out experimentally. The one if, oh, that, is that part of, we're setting that to 8 and then setting it to 12? That's weird. I'm a little surprised that GCC generated code for this, because this is a dead store. There's nothing special about G timers that GCC would think that it's like a memory mapped device. Yeah, usually it could be the array access that's throwing off GCC. Like if it was field access, like just a normal field. I think that GCC would have done the right thing and gotten rid of that assignment. It knows the offsets of all three of these values, and so it should know that this right does nothing. And it doesn't do the right. So it actually does not do this right. Looking at the assembly, what this does is forces the load of the address, but then the write never happens. But the optimizer isn't smart enough to know that the address is already loaded. Okay, whatever. The assembly shows an arg to the func. This is just pushing things to the stack. Is that what you're talking about? So it's pushing the stack pointer to the stack, and then pushing the return address to the stack, or to sorry, it's incrementing the stack pointer, and then pushing the return address to the stack, and then I don't know why 1C to load immediate to B0. Where's that? Load immediate 8. Oh yeah, it's doing that too. You're right. So yeah, again, I don't know what the state, like what the AST looks like when the optimizer gets it. So at some point during this branch, the compiler thought in the branch delay slot, so that no matter what happens with this branch here, this branch instruction, whether it's equal to 0 or not, this 1C instruction is always going to get executed. That's called the branch delay slot. When we look at the SPIM disassembly of it, SPIM indents those to make them very obvious. And it's funny, it actually disassembles as a slightly different instruction. They have the same. I don't know which one's the. I guess the load immediate is the pseudo instruction, and this is more close to the original machine instruction. So regardless of the branch, we're going to load this 8, and I think basically what's happening is there's nothing that can be done before this function call, which has its own branch delay slot, because there's no arguments to the function call, and the function call doesn't return anything, so we don't have to preserve v0. Or at least if it does, if it did return something, we would have to, preserve v0. So it's going to, since it has nothing better to do, and it sees that there's an assignment of an 8 down here, it says I might as well throw that in the branch delay slot instead of doing a no op. And then if the branch fails, hey, there's an 8 there, and somebody can use the 8. But then the compiler comes down, and oh, you're right. You're so right. It does do the store. Weird. Yeah, I was thinking it was just loading the address, but loading an address looks something more like this, where it loads the upper 16 bits and then loads the lower 16 bits. So anyway, it is doing the store. Double store, dead store. Bad optimizer. We could use a higher optimization level, see if it works any better. Works. On to the next. This is also not a duplicate. So these are pretty simple. I would have to go through and look at who's calling them and for what reason, but so this first one, this D74, it's setting the state machine to a particular place. It's loading a particular animation, so the animation frames are loaded in a specific area of memory, and it knows what the indexes are. So this is just an array of indexes into that animation. Setting Richter's speed and setting it to 2.25, 2.25. Setting this timer, so we don't have a name for that timer yet, but then there's something else that gets created, and that's specified by this 5001. Either the 5 or the 1, I don't remember which, is an index into the entity table to tell it what entity to create. And then that will be its own thing. So if you're Alucard, for example, and you start walking, that might be the trail behind Alucard. We'd have to look at what calls this to see if we can tell what entities might be being created. The function down below is similar. It's not responsible for decrementing its timers, just setting them and checking them for 0. Something else, it's relying on something else to set it for 0. We could look at, actually, let's go look at what these steps are. I think we know what both of them are. Yes, we do. So this is running. So yeah, I might have been right. That might have been the trail behind Richter when he's running. And then the other one is step 2, walking. So it probably is going from running to walking, and maybe the timer is like how much longer is that trail gonna stick around, something like that. A lot of little ones. So the most interesting thing here is this block 6, which we're not going to end up needing. And so we just have to make sure that everything falls through the same way once we get rid of block 6. I'm going to get this to compile first, and then we'll go ahead. This first variable is going to be a signed 16 array. And then the second is also going to be a signed 16 array. Get rid of the function signatures. And this compiles just fine the way it is, but we, with very limited exception, there's no go-tos in this code. So we're going to restructure this to not have go-tos. We need to get rid of all of these symbols that are actually references to fields in different structs. I like starting with grick. Let's do it again. Okay. So this is still compiling fine. So the first thing we're going to do, if we follow this code path here and go to block 6, really this is just sharing the code to assign the unknown 44 field. So we're going to come down to here, jump down here, and then the next thing that's going to happen is we call the set step and velocity. So we have to make sure that that happens. So if we just copied this line up here, that's not what's going to happen. We would hit this, and then jump down there. So what probably happened was there was an else. And then now that gives us the same control flow. And that was our only thing that was calling that block 6. The other thing is, what is this assignment doing? It's just assigning a static value. Bar v0 is probably the register that it used temporarily. We don't care. The compiler can choose whatever register it wants. And because of how this works, we can be pretty sure it's going to choose the same direction. This might not be a quality check. We'd have to look at the PSP version to double check that. These have been going so quickly and easily, though, I'm not going to go back and check that. This is the first hard thing. And is it that hard? B, how far is B away from 0? B is 5, B is 11, right? So this is negative 5.5, I think. We could check that. So we just want to make sure that our hex values, they get split over 2 instructions, because we can only load 16 bits at a time in MIPS 32-bit. So we want a fix negative 5.5. 5 and 5/16. What is 5/16? Is that even a... Why? A 16th is half of 0.125, 0.0675. So let's see if I can get this right. 5.5675. No, 625. Am I close? Or, and then, oh, because we're going the other direction. 6.375. Yep, that's why. Sorry, I'm poking around, trying to find the right value here. So we need to go. It's not going to be 6. Lower. No, higher. Lower. Let's. Oh, we're getting close. Not close enough. Too far. Yep. Let's stop messing around and sorry, I'm just poking different numbers into this, and this is why I write little tools to do this for me, so I don't have to think. Who wants to think? I could do 5 plus 5/16, but what fun would that be? Gross. 46875. Okay, I'll go with that. Very close enough. So I've mentioned before, we don't have a floating point. So we can't do floating point math at runtime, but we can do floating point math at compile time. And so the compiler will take care of that for us. I was close. I got pretty close. Anything else with this? I don't think so. So what are we doing here? We're let's paste this. Looking at the direction Richter's facing. it's unclear to me, like going through all this, there's a function to check the way the Richter boss is facing, but other places in the code look at the facing field in the Rick entity. And so why do some do that and why do some do the other? I don't know. We also know that this works if we're sliding. So this is part of the Richter slide logic. And so if we're sliding, it looks like it's going to go into a running animation as well. So maybe this is like a slide and turn, because our velocity ends up going in the opposite direction. And we have this up here as well. Might as well change that. It's a fixed 2.25. Line 15, remove the pointer. Yes, thank you, the reference. Can do. We don't have a lot of warnings turned on for GCC, and the warnings that are available in like this 1997-ish version of GCC are suboptimal. There's a lot of warnings that I would like to turn on that we can't. And so we would get a warning if I was doing the portable build, but not with GCC. We might get a warning with MetroWorks. I don't know. So we're gonna go and look for this one. Also not a dupe. Not any longer. It's kind of scraping the bottom of these small ones. Who wants to do some Dora decomp? It's crazy that Dora it was around then and is still around now. This timer's, I thought I had enough to make add a symbol for. The order that velocity X and velocity Y are being done here is slightly sus. So I'll be interested to see what is going on there. The 165A looks like it is possibly part of GRIC. I think we've seen 156A today. Have we? Yeah, because the other one is 4F. Alright, so I'm going to guess that this timer is 11. Could be wrong. And then another animation array. Start going quick. I think this is right. We'll soon find out. It is not right. Am I close? Not anywhere close. Oh, brain. So we're 5A minus E away from that timer. So it is part of GRIC, as far as I can tell. Everything else looks the same. So we're 4C after that timer. So let's take... A is going to be 5 timers in. A is 20 bytes in. So I'll add this and then subtract 20 bytes. Let's try this address. Unknown 18. Yuck. I don't like that. We'll try it. Yeah, that didn't feel right. Am I closer? I am. I'm still 2A bytes away. So, this address plus 2A. This one F62. High jump timer. I like that. And that's what it is. Yeah, still GRIC. I'm gonna clean and build. And then what I'm going to do is look to see what is left. Things without... I'm going to focus on things with automatic symbols. I think everything in Richter is a duplicate. So there's this 3914 file. That might be the last... There's the cutscene stuff that I still haven't figured out. I haven't gone back to it, though, since we did it on the stream. So I like to use find US boss BO6 non-matchings. Yeah, so still quite a few entity player blink white. I've mentioned before, this is a crazy function. I did the doppelganger one, which was largely the same as the Alucard one. Basically, it looks at the sprite data and traces around it, and so it's an algorithm for drawing the outline. The outline itself is not a sprite. And I think the outline actually radiates, right? So, complicated function. Fortunately, it's been solved already, so we don't have to worry too much. I think maybe tomorrow we'll go through and maybe look at one of these larger ones. Unless there's something specific that people want to look at. And I'm happy to do that as well. So there's... Thinking about what is left, there's a lot left. But what is interesting that's left, or what problems don't we know yet, or haven't we solved? The major one is Saturn. Not a lot of work has been done on Saturn yet, but we have just about one of everything. Oh, Progress is not happy with us. We have one of just about everything. All of the servants, with the exception of one function, which is a bunch of 3D motion for the Sword Familiar is done. I know more about the GTE macros now. So that's possible, but it's relatively straightforward to do. Unfortunately, I think it's basically the same function on the PSP. I'm a little curious as to what... let's look at bosses. Or let's look at the remaining bins and see if their bin sizes are different. So we're gonna find this US and look for bins. Field 711 is the size and the name of the file. So all these are padded, so you can't really tell, unfortunately, what... Oh, I guess only the servants are padded. So we do have a relatively good idea of... Oh, the bosses are padded too. And some of the stages. Oh no, that's just the graphics for the stages. Oh no, so yeah, we do have a pretty good idea of how big some of these bosses are. RBO3 was Medusa. That's probably why that one was chosen and completed. So RBO1 is Beelzebub. That's the next smallest. Kind of interesting, the flies. Seem like they could be complicated. Where does RBO, or where does BO6 fit into this? Not seeing BO6. BO6 is on the bigger side. RBO5 and BO4, so this is Doppelganger, Reverse Doppelganger, Doppelganger 10, Doppelganger 40, and then Richter. Those are bigger than some stages. So we'll get those done though, and those are the big ones. And really it's just time getting some of these done. It's just time. Hey OTM BN90, good to have you. I'm just wrapping up, and I think that's what we'll do. I should clean up what I have, submit a PR. It's big, and nobody will look at it. It'll just get merged in. That's the way things go sometimes, though. We're decompiling Castlevania Symphony of the Night, and if you want to see more, you can go to soten.z.dev and find a link to Discord and a link to GitHub. And if you're interested in decompiling, I'm here Monday through Thursday for about an hour and a half, 2 hours or so, chatting and decompiling with you guys. We've been working on Richter, and that's about it. Talking about weapons, PSP, different architectural concerns. We'll be back tomorrow. Adios.